We're going to look at this video at a couple of lines, real life examples. We're using straight lines. These are lines in context or real life graphs. Now, first thing we want to do in this question says find the equation connecting the charge C with the time t. So let's read the example. It says a TV repair company charges customers according to the graph below. So you can see on the vertical, you've got your charges C, and this units are going to be pounds, and your time t in minutes. So we want to find the equation connecting this. So we're going to do this, think about this as in terms of our y equals mx plus c. So if you think back to y equals mx plus c, m is your gradient and small c is your intercept. Now we're going to change this because on the y axis, what we really have is c. So it is big C is equal to m times your time t, and then plus your small c for your vertical intercept, I'm going to call it this time. So we can read off a few of these things. So here it tells you on this thing, it tells you 12 is your small c. So your small c is equal to 12. The intercept, the vertical intercept I'm going to call it, and your gradient m is going to be equal to, remember, rise over run. And they have been very helpful to us here, and they've given you a wee bit of information. So the rise over run is going to be 12 over 20, and which cancels down to be 6 over 10, which you might want to just write as 0.6. So your equation is now big C is equal to 0.6 times t, and then plus our small c, our vertical intercept, was 12. So I'm going to put that in a wee box because we can use that then to do whatever we want. Okay, next part of the question says, what does the y-intercept, the vertical intercept of this line represent? So if you imagine it says a TV repair company charges customers according to the graph below. It costs, if the person is out for 0 minutes, it costs you £12. So what on earth does that mean? That means it's what's called a call-out fee. So when you call somebody out, a plumber or an electrician or whatever it is, even if they don't do any work, once they come out, they charge a certain amount of money. So that £12 would represent the call-out charge. So we'll just write that in now. So that's the call-out charge. Okay, and what does the gradient of this line represent? So this would be the number of pounds that the person gets per minute. So you imagine here we'll pick this example here, we'll pick a nice one if there is a nice one. Here we'll pick this one here. We'll use this point to explain it. So this person's been charged £60, and the person who's doing the servicing was out for 80 minutes. So 0.6 is the cost in pounds per minute. Okay, so if you just check that in your calculator, so they've been out for 80 minutes, so 0.6 times 80 minutes, and then plus 12, and that takes you to 60. So you can see that is right. So the gradient represents the 0.6, that represents the cost in pounds per minute. Okay, next one says a man is charged £84. How long did it take to fix his TV? So he's charged £84. Now look at this. Unfortunately, you cannot just use your graph. So say it had said a man is charged £40. You could, absolutely right, absolutely fine if you just go across 40 and down, no problem. But here we can't do this. So we've got to put this into this equation. So we're just going to say, for this is your part D, just squeezing this on here, we're going to say let 84 equal 0.6t plus 12. And then what we want to do is bring the 12 across. You'll have 84 minus 12 is equal to 0.6t. 84 minus 12 will be 72 is equal to 0.6t. And then we'll go over here. That means 72 divided by 0.6 is equal to t. and then your t works out to be, so let's just do this, 72 divided by 0.6, press equals, you get 120 minutes. And 120 minutes you could write a lot nicer as 2 hours. In this example it says a mobile phone contract costs £10 per month and then £2 for every 1 gigabyte of data that is used. Complete the table below and use it to draw a straight line graph. It says don't forget to label the axes, so we've got to do that. So you've got your cost is going to be on your vertical. So this is your cost, put in brackets, this is in pounds, and on the horizontal, this is your data. I will say this is GB for gigabytes. So we're ready to get started. It says a mobile phone contract costs £10 per month, then £2 for every 1 gigabyte of data. So this one here is going to be 1 gigabyte is going to cost you £10, the initial £10, plus £2, so it's going to cost you £12. Next one is going to cost you £10 plus 2 times 2, so it's going to be £14. Next one is going to cost you £10 plus 3 times 2, so it's going to cost you 16. Just be careful, we've jumped now to 5, so this is going to cost you £10 plus 2 times 5, so it's going to cost you 20. We are now ready to draw our graph, so we're going to put in these 4 points. So at 1 gigabyte it costs £12, at 2 gigabytes it costs £14, at 3 gigabytes it costs £16, at 5 gigabytes it costs £20. So we're just going to plot those 4 points now. So at 1 gigabyte we're here, we're at 12, at 2 gigabytes we're here, we're at 14, at 3 gigabytes we're at 16, and at 5 gigabytes we're up here, we're at 20. Now I'm going to pause the video here and I'm going to try my best to draw a straight line. It's very difficult to draw straight lines on this. I will give it my best shot to draw a straight line and then I will come back to you. Okay, I'm fairly happy with that one. We've got our straight line drawn and now we're ready to, so you should be able to do that, and then we are now ready to look at the question. So the question says, what is the intercept of this line and what does it represent? Okay, so first of all, the intercept, we'll just say intercept is 10, and that is just the cost if you use no data at all. So if you use no data, it still costs you £10 to have this contract. So remember, it was cost. The cost was £10 initially, and then it was £2 for every 1 gigabyte of data. Okay, I've sort of answered the question there for part C. It says, what is the gradient of this line and what does it represent? Well, let's just look at the gradient first of all. So I'm going to pick this point, and I'm going to pick this far away point up here. So if I do a wee dashed line along here and link this up as a right angle triangle, you probably already know the answer for this, but if you do this, you can say your gradient is equal to, remember, rise over run. So in this case, your gradient is, I've gone up here, my vertical is from 10 up to 20, so it is 10, and my run is 1, 2, 3, 4, 5, so it's 10 divided by 5, which is 2. So my gradient, we'll just say gradient equals 2, and that is a cost in pounds for each gigabyte used. Okay, last part says, what would the monthly cost be if you used 10 gigabytes? Now, as you can see here, our graph only goes up to 6 gigabytes, so we can't use this. So our what we're going to use is the fact that 10 gigabytes is going to cost you £10 initially, plus, and I've got 10 lots of £2, and if you do that, 10 plus 10 times 2 is 10 plus the same as 10 plus 20, which is going to be just £30. And that is it. Okay, so there's two examples on real life graphs or graphs, line graphs in context. So we should be okay with those questions.